a little bit about me. I think I gave a little bit of an intro last time, but I'll risk repeating myself. I started my career as an academic labor economist. So it, kind of came at HR analytics, not through organizational psychology, which I know is probably the most common background, but through economics, but still had a pretty big focus on talent and analyzing employees. And then started working at IBM in their chief analytics office, where I eventually started running the workforce team in the chief analytics office at IBM. So we worked on a lot of HR analytics projects, reskilling, site selection, promotion strategy, retention, all the likely suspects. And it was really while I was there that started thinking, and actually Stella was very, very instrumental in this very early brainstorming, kind of how to sort of scale this analysis. So really thought, if we could potentially get away from using internal HR data, and use only public sources, can we kind of reconstruct the HR database for every company? With things like online profiles from LinkedIn, stuff like that, job postings, immigration filings, whatever we can find, O Net, and if we can bring all these sources in and kind of reconstruct a global HR database, then a lot of what we do in HR analytics can scale, and we can have the added benefit that we can compare to competitors. So at IBM, we did a lot of analytics on our own internal data, but we had no clue what was happening at Accenture or Microsoft or anyone else. So the ability, this is something they talk about in the business school a lot, but a strategy at its core is about differentiation. So if we're doing strategic workforce planning, we really need to have a sense of how we're differentiated as a company. So that was kind of the idea behind Revelio Labs, which started almost 2 years ago. So creating occupational taxonomies is a really core part of making sure you can compare between companies, because every company's got a different way of understanding their workforce. Right now, we're mostly selling these insights to hedge funds and private equity firms, so that we can get Wall Street to care about HR data and convince CEOs and CFOs from a different angle. So fighting the same fight, but on a different, from a different direction. So that's.
Does Revelio mean what? How did you come up with a name for your company?
Well, we're revealing something. There's a lot of hidden data that is unknown, and it's from Harry Potter.
Okay.
Yeah.
All right, now we can get back into the trenches here.
Yeah.
I think.
So just actually even before we get started, something I want to say just from doing HR analytics. I imagine a lot of you do HR analytics at a company, right? Could nod or whatever. So my sense of what that's like, and it's been a few years, so forgive me if I'm like misplacing this a little bit, but you get a lot of requests, and a lot of people care about your analysis. They want you to do some analysis, and it's very easy to kind of get overrun with requests. Sometimes they're different, sometimes they're custom, but sometimes they're the same. So sometimes you end up duplicating effort. And I think one of the big benefits of doing HR analytics in a tool like Python, and something we'll touch upon further today, is around kind of productizing what you're doing. So that's really the focus of this second session. We want to take this analysis that we did, which you could potentially do in Excel or SPSS or something like that, or Tableau, who knows? But I wouldn't recommend it. But what the real benefit of doing this in Python is that you get to make functions, and we'll talk a little bit about functions and how they work, so that you just create a wrapper around everything you've written, and then you can do this analysis on new data, on new inputs, just like that. And it becomes kind of like a product. So I think if you take the upfront cost of getting becoming proficient in these tools, Peter said it takes 6 to 9 months, but we can get it down to 2. then you really have the benefit of next time you're asked a new request, you can take a little bit longer and turn it into a product. And then you sort of shift your, how you interact with the business from being more responsive to having something that you can put out there, that you create, that anyone in the organization can use. So I think that, in my mind, that would be like a really great place for HR analytics to get to, making HR analytics products for an organization. So that's the dream. Questions or anything about that little commentary?
Ben, in addition to the Python download, and I suspect majority of people were on the call last week, do they need anything else? Will they need access to the same workbook? Because I'm trying to post so those who haven't had the chance to be part of it, they can catch up. Yes.
So we will need the same notebook. It's on GitHub. I just shared it. Oh, okay. So yeah, you can find the Jupyter notebook, and we just copy the code. You can run it in your own internal notebook. And when you run it internally, you can tweak it, you can customize it, you can choose different occupations to focus on. So you can mess around with it yourself. Okay. Sound good? All right. So let me. I think I need access to share my screen. Okay, cool. All right, let me, okay. Can everyone see this? Can see my screen? Okay, so we opened a notebook here. And this was the exact same thing you did last session. So let me just run through and do a little bit of review. So we're analyzing occupations. We imported packages. Packages are a collection of functions. So actually, let me take a minute to talk a little bit more in depth about functions, because we'll be building our own a little bit later. So so a function is actually, anyone want to shout out and define a function? All right, I'll just say it. So a function is anything that takes an input and returns an output, right? So you can think of a factory as a function. You take in a bunch of people and inventory and whatever, and out comes a good or a service or whatever. You can think of the economy as a function. You take capital and labor, and you get goods and services. Yeah, so a function is really an input-output process where you don't really need to know how the sausage is made. You need to know there's some manufacturing in the middle, there's some machinery, but at the end you care about your input and you care about your output, and that machinery is hidden from you. So we have this read Excel function. So that's the first thing. This is a PD is pandas. Pandas is the data analysis package in Python. And that's a function where we can take in an Excel file and output a something. It's called a data frame in pandas, and we call that BLS. That's from Bureau of Labor Statistics. So we run this, and we run this code, and out comes some objects that we can then manipulate. So we imported packages. Those are just tools, functions that other people have written. We read in data from the Bureau of Labor Statistics so that we can know the population, the salaries, the growth rates, anything we want to know about occupations. We need to do some cleaning here. There's something called wage that we want to turn into a number so that we can do calculations on it. And this is what the data looks like from the Bureau of Labor Statistics. And then we started reading in data from O Net. So O Net is the occupational network. Here's what it looks like. Still loading. But O Net has details about occupations. So I think we used activities somewhere. Where is that? Work activities. So we right-clicked on this text file, which is the activities associated with each occupation. We copied the link address, and we used the link address right here. And we just pasted that in. So those are the work activities, and that really is kind of the composition of an occupation. An occupation really is just a set of activities, right? So we read that in. Again, in order to execute a cell, we need to press Shift-Enter. So then we took a look at what that looked like. Here's what the activity's still reading in. Maybe it takes a few seconds. So we're reading in that. We're cleaning up the SOC code. So the SOC code is the occupational code. Why not use Excel file? Good question. We could. There's a text file, and there's an Excel file, there's MySQL, there's Oracle. We could have used either of these files, but Excel is a very heavy format. So Excel files are like 10 times bigger than they need to be because they have added functionality. Excel can do a lot of things other than store data. So if you just want the data in its cleanest way with no bells and whistles, a text file is the simplest way to store a file. So it's much faster to read in text files. So when you're passing data back and forth, typically you use CSVs or text files. Okay, so this is what the data looks like. So we have all these elements, getting information, monitoring processes. These are the details of an occupation, and every occupation, every code here gets scored by how much it uses this certain activity. We cleaned this, and then we merged in Bureau of Labor Statistics data, and then we took the and then basically for every occupation, we calculated the number of employees and the value of that data. And we ended up making a pivot table. So pivot tables where we have occupations on our index as our rows and activities as our columns. So we ran this, and out comes this file, which is which has all the occupations. And here we don't even need the head right there. So here, let's see what it looks like. So we go all the way down. It's got 752 occupations. So every occupation is a row, and 41 columns. So every activity is a column. So the data is a text file, which actually is like a CSV is a text file. It's just a text file that is separated by commas. This is a text file that's separated by tabs, but we use read CSV because that's just the read function for every text file. A CSV is just a special type of text file. Okay, so now that we've got 41 values for every occupation, we call this a feature vector of an occupation. So a vector is a row or a column. It's just a sequence of numbers. And so we have a sequence of numbers for accountants and auditors. So we have 41 values. Then we have a sequence of numbers for actors. Then we have a sequence of numbers for actuaries. So we call that the feature vector. It's a vector because it's a sequence of numbers, and it's a feature vector because it's got these features, which are activities. Okay, then we did something called tsni, which takes these 41 activities, these 41 dimensions, and we compress it down to 2 dimensions in a way where we can maintain the distance between things that are very close. So let's see what that looks like. So we have this value 0 and 1. So 0 and 1 don't actually mean anything, but they encompass all the information in these 41 activities. So we try to take these 41 and compress it down to 2. And that's what these 0 and 1 represent. Okay, and then we make a scatter plot using this package we imported called Plotly. And Plotly is really nice because the visualizations are interactive. So this looks like nothing, but if you hover over things, you can see accountants and auditors are next to financial examiners. That is really nice. Kind of makes sense. They're also next to cost estimators. Totally makes sense. So you can kind of hover over and eyeball whether things look right. Over here, there's like bus and truck mechanics and automotive service technicians. So far, not bad. So this is the occupational landscape, sort of. And we can add these nice little features, make high-paid occupations show up in yellow, and low-paid occupations in a darker blue, and sort of plot the salary spectrum. And the size of the dot is how populous it is, how common of an occupation it is. Okay. So now that we did that, we have the similarities. We have the similarities between occupations, and we make this thing called dis activities. So what we're doing, we're taking the distance between activities, between the representation of activities, which is this data frame here. So we take this data frame and we try to compute the distance of every occupation to every other occupation, based on how close it is to something else in these columns. So we see accountants and auditors and analyzing data and information is 5.2, pretty high. Actors is very far. So in this dimension, they'd be pretty far. In this dimension, they're kind of close. You know, so we score the distance between these occupations in each of these dimensions. So that,
Ben,
yeah.
There's a question from Michael. Is it proximity from having similar activities in each occupation?
Exactly. So it takes the difference. Here, I could, yeah, I'll walk through exactly how this works. Yeah. So let's say we want to know the difference.
And one more question related to this. Are you calculating skill similarity? I think that will probably come to the explanation.
Activity similarity. We'll get to skills in a bit. Yeah. We can do this for skill based on skills as well. So right now, well, actually, I mean, we're doing occupational similarity, and we're doing that based on activities. We could also do occupational similarity based on skills, and we'll get to that today. So we basically take if we want the difference between accountants and actors, we take this thing 5 minus 1, and we have 4, and we square it, and that gives us a Euclidean distance. And then we take 2.4 minus 1.8.6, square that. Square that, sum it all up, and that's the distance. And you know, so it's the average squared distance. And so this function does that, and we get these activities. So now we see why square it. It's because Euclidean distance is, you know, you can kind of think of you know, a triangle. If you want the length of a hypotenuse from 2 different points, you do a squared plus b squared equals c squared. So it gives you straight line distance. You can also do, you know, kind of, they actually call it Manhattan distance, funnily enough, where you actually just do it without squaring. Yeah, so Manhattan distance is called L1 distance. Euclidean distance is called L2 distance. Don't get fancy, but Euclidean distance is more common. Okay, so now we see the distance between accountants and actors is 13.9. That's okay. So that actually is this average squared deviation. Okay. So then let's say we want to check out HR people. So we look at HR managers. So we search for things that contain the substring human resources, and we select human resources. So let me actually show you what happens. So we have dis activities, right? So this is the whole distance. This is a 752 by 752 matrix. Okay. Then let's say we only want to select the column of HR managers. Now we have the distance of HR managers from every other occupation alphabetically. So you know, we get accountants, then actors, and actuaries. But if we want to sort to the most similar things, we do sort underscore values. And now we see that education administrators is closer. Training and development managers is right there. That kind of makes sense. And we could just take, you know, the top 10 and see what we get. So here are the top 10 occupations. We could also merge in the employment, the wages, just to see if there's anything close that has higher wages. I think last time we picked out chief executives. So then we take, so then you might want to retrain. Maybe not, but you know, some of you. So then we have our source and our target. So we're storing this string, which is this text, and we're storing this text. And then we're saying we want the activities, the activity score of the target. Let's see what that looks like. And, oh, whoops. That is, we need to run this first and get the target. Okay, so then we get all the activities. So here's analyzing data and information, assisting and caring for others, coaching and development. So we have all these scores for chief executives. And we can also get all these scores for the source. And so we have all these scores, the scores for the target, the scores for the source. And we just take the difference. We take the target minus the source, And then we sort these values, and that will give us the gaps, right? Whatever's high in the target and low in the source, those are the gaps. And whatever's the opposite, so if we sort in the other direction, then those are the things that we have extra of. So then we were able to examine the gaps you'd need to fill if you wanted to move from an HR manager to a chief executive. So this is just one example of what we can do now that we have this distance matrix and representations of every occupation by activity. Okay, and that's really where we ended last time. And we're already halfway through, so just to review. But anyway, the rest shouldn't take too long. So the rest, we want to make this more polished. We want this to look good. So we can do the plot. So making the plot look nice is, there are some samples online. So here's some example code that you can just copy and paste. Here's my advice for making visualizations in Python, R, whatever you do. I don't think it's worth learning all the details about making plots. I think the best way to get started in this is copying other people's code. These Plotly has great resources, and they give you all the code. They have tons of examples, and I think I copied something pretty much directly from them. Here, where did I copy? So they have all sorts of nice stuff. I don't know exactly where it is, but there's some examples. You can kind of hover over and find things that you like about each plot and what you want to copy and paste into your code. So that's kind of what I did. So one thing is, let's just go back to where we were last time and see what we don't like about it. One, when you hover over, it says all this stuff that we don't necessarily care about. Let's see, it's kind of like a little too, like the shape of it. It's, we'd want it to be more like a square probably than this rectangle. This 0 and 1 don't really mean anything. So I don't know, we can, so here's what we did. You don't have to keep everything when you hover. We renamed this dimension 0 and dimension 1. We gave it a title. Now it says Occupational Landscape on top. We gave it a width and a height. We changed the font. So now it's this font family called Rockwell. So now we have just the details we care about. Just the name and the wage, which is maybe all we're concerned with. And yeah, it looks more like a square. I just did it kind of to fit my screen. I don't know, I think it looks a little nicer, a little more polished. You can tweak this endlessly. So, and it's a real rabbit hole. When you want to make like a really nice plot, I mean, you can like find all sorts of ways to customize this. Okay, so now we have this nice little plot. It's a little more polished. Okay, now we wanna turn this into a product. So we need to make functions. The way that functions work is we first use DEF. DEF means define. We're defining a function, and we call it something. Here I called it rep from O Net element. So here, let me just write this from scratch so we can all do it together. So we're defining rep from O Net. It's underscores because it's got to be one word. And then we want, in the parentheses, we want to put what the input is. So we want to do, well, no, you can't use the word input. The input in this case is a URL. We're going to take a URL, and then we are going to, here, I'll just write it exactly the same way. Okay, so we're going to take a URL, and we're going to get the representation. So last time we got rep activities from O Net. So we do colon, and then we're going to define it. So first we read it in. So here, let me go back to the initial thing and just copy the code that we want. Basically everything, right? So let's think. We read in activities. That's this thing. We changed the SOP code to whatever. We did this. We merged with BLS. So here, let's copy all this stuff. Okay, so we're gonna copy that, and we are just gonna paste it into a cell here. This was all the code we had. I just copied and pasted the code. We can delete the stuff that we don't really need. Just the code. We don't need to look at the header. We just did the merge. Fine, we have this line, we sum it, we have all these lines, we divide by weight, blah, 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 blah. Fine. This is all the code. That's all the code just in one nice little block. So what we want to do, we want to do the pd.read CSV, but we want the URL to be an input. So we're going to put in a new input. So we're going to copy this line and we're going to put it right there. And we're going to define that. So we're going to replace this with URL. And we are going to call that element. Okay, great. Now we read it in. Now we actually have to do all this stuff to activities. So we can just put that there. We got to make sure it's indented so it's all part of the same thing. But now every time we do something to activities, we just do it for element. So let's just replace activities with element all across the board. So instead of doing this thing to this thing called activities, now we're doing it for anything which is a placeholder for whatever we're reading in. It doesn't have to be activities. It could be skills. So great. Now we have that. We also made it at the occupation level. So let's do that too. So we could call this element occupation level. And there we go. We did the exact same thing as before. We're just replacing activities with something more generic, more broad. Okay. I think we called that element D. I don't know, whatever. So basically, the point is we are copying and pasting the code, but we are creating a more abstract version of it. So we're not defining something as activities. We're just creating an element, something called element. But then at the end of the day, we're just gonna rename our items here so that they're more abstract, so that they're not just referring to activities. And then what we're gonna return, the output of this function is going to be a pivot table, which is the rep activities. So now that we've done all that, by the way, if you want to block out some code, you do command / and it just blocks it out. And it's really nice if you want to you don't want to delete your code because you want to see it, you want to remember what you did, but you don't want it to run. So we run that and it doesn't do anything. So this we can delete because it's all down there. Okay, so now we define this function, rep from element. And now we can create something called rep knowledge, which is just using the knowledge URL. So we do rep from O Net element, which is this thing we just created that didn't exist a second ago. And we put in the URL that we care about. And let's check it out. It's running because it's actually running all this code inside the function. So, you know, it's taking a few minutes, or not a few minutes, hopefully less than 10 seconds. But then we can do this for skills also. So we don't just have to represent occupations based on activities. It seems like a reasonable way to go. You know, an occupation is a set of activities, but maybe you want to think of an occupation differently. Maybe you want to think about an occupation as a composition of knowledge that you acquire. So now we see that accountants and auditors have administration and management, biology. They don't need to know much biology, I guess. Building and construction, chemistry. So there's all these kind of subjects that, and you can think of an occupation as existing in a different space, sort of, in kind of knowledge space rather than activity space, if you like to think that way. But I think what we're really doing is we're actually representing an occupation by, in this case, it's 33 features. Each feature is an element of knowledge. We could do the same thing with skills. So there's a collection of skills also, and we can think of every occupation as having some score for different skill categories. So the really nice thing is that we just had one line where we created this data frame, which we did before. So active learning, active listening, complex problem solving, coordination, these are all skills, or kind of categories of skills that an occupation can have. And that's a very useful way to think about occupations in some contexts. Certainly for training, thinking about an occupation as a collection of skills could be very useful. Okay, so now that we have that, we can do this gaps and excesses thing that we did before. So here we're actually defining, it's a much simpler function, but it has more inputs. It's not just a URL this time. Now we actually have 4 inputs. We need our source thing, we need our source occupation, we need our target occupation, and we need the representation that we want. So last time we did this based on activities, but it doesn't have to be from activities. It could be based on skills and the number that we'd like to see. In this case, the default, I guess we could pick 6, like the top gaps and gluts. So we define this function, and there we can see HR managers and chief executives, top 5 in skills. So these are the skills you need to develop if you want to become a chief executive: operational analysis, operational control, systems analysis, stuff like that. Here are the things you will need less of: programming, instruction, social perceptiveness. These are things that you already do, I guess. And we can also look at knowledge. So we can look at knowledge that exists in your target, but not in your source. So yeah, I don't know. I mean, these things seem a little weird. I don't know why chief executives need to know chemistry, but who knows? Okay, so the point is, I mean, basically what we did before with, a bunch of different, with a bunch of code, we can do very simply now. We can do just with one line because we already turned it into a function. We just need to give in these inputs. We need to put in our source, target, the representation that we want to learn it from, and how many we'd like to see. By the way, if we just leave this out, it'll just default to n equals 6, which we did before. CEOs need to know the chemistry of human relationships. Well, so do HR managers. But yeah, I guess that's right. Okay, so yeah, this might be a good tool for career planning. I think that's right. I mean, I think this, this is pretty broad. I mean, basically what we've done is just taken occupational data and just try to understand occupations more deeply. This is great for job seekers, maybe for HR professionals doing planning in an organization. So yeah, I mean, it's a pretty diverse set of capabilities, I think. So that's sort of the goal. So now that we've created functions, we can do this in just, one line. We just need to find the URL from here, and that's easy enough to do. Here's skills. We just copy the link address from skills, and we've got it. We can do it for abilities, for education. We could do it for a bunch of different things. And I encourage you to go crazy on your own. So now we've got functions to do that. What about the rest of what we were doing? We also made this hover plot. Now, okay, so except that the models are based off input from employers, not so much based off of job design analysis. Yeah, I mean, I think one of the constraints here with this type of analysis is that this is specifically built based off of using O Net data. If you wanted to use a different type of data, like your own internal company data, it would be structured a little differently. You'd have to do your filtering differently. You'd have to, group by and aggregate differently. But fundamentally, I think it's the same process. So I think, yeah, I mean, if you can do this based on what you find in an organization or publicly or whatever, then yeah, and yeah, so I think that there is some tweaking to do. I don't want to say this is like an out-of-the-box product that you can use in an organization, because they're going to have different taxonomies and stuff like that. And for career planning, yeah, I mean, there's of course this big issue that every company has different ways of categorizing people. So there's definitely a fair share of barriers, but might be a good start. Okay, so when we did, when we made functions before, we made 2 functions, and each one, oh, actually, just the first one had an input, which was the URL, and what gets returned. So the last line is what gets returned in the function. Now, in the other functions, we actually did not have a return item, but something was printed. So we just said, oh, give us this input and just run this thing and print something. So then we don't actually store anything from this function. it's just something to print. So we print this little table here. And with the hover plot, we want to create the hover plot, and this also does not have a return object. We're not returning anything. We're just presenting a plot. So we do tsni, which gets this embedding, and we merge in the BLS to get the counts and the wage. We take the square root. We rename these things, and we use this scatter plot that we just made, which is kind of the fancier version of it. So we run this function. It never takes any time to define a function, but to actually run it, this might take a few seconds because we're doing tsni. So let's see how long it takes. And now we're going to make this hover plot based on skills. So instead of hovering over things and seeing which occupations were close to each other based on activities, now we're seeing which occupations are close to each other based on skills. So we can see preschool teachers, flight attendants, psychiatric aides. Probably don't have the same activities, but maybe need to have similar types of skills. If you're a flight attendant, you're doing very different things than if you're a preschool teacher, but you need to have the same kind of, I don't know, I guess you need to have the same type of skills. Let's see what else. General managers, transportation, education. Okay. Sales managers, HR managers. Okay. Doing a lot of sales. This one, I don't know. Physicians, surgeons. Okay. I mean, you can peruse on your own. I mean, we can also do this based on, should we try this based on knowledge and see what it looks like? So all it takes as an input is the representation. So we have the representation of skills, knowledge, of activities. And so we can certainly do the same thing. And now we have this occupational landscape based on knowledge. So yeah, I mean, I don't know, you can peruse on your own and see if it looks good, if it looks useful. Okay, and then the next thing we did was we actually searched for jobs using a substring. We could turn this into a function, even though it's sort of minimal. So for me, I want to look up economists. I want to see what's similar to economists because I'm an economist. But for you guys, you can search for anything you might find interesting. So the reason why we search is so that we have to get the exact text of how it's stored. And then we can define this other thing, which is find similar. So we want to find similar occupations. So if we want to find something similar, we need the occupation, the source. In this case, it's going to be economist. We also need similar in what space. So what representation? Similar in terms of knowledge, similar in terms of skills, similar in terms of activities. That's an open question. So that has to be an input. Which representation we want to use and how many we want. By default, it's 10. You can deviate from that. So we just create this distance matrix and define by selecting that occupation and sorting values and then picking the top X, whatever, the top N. So we're going to find similar things to economists based on skills. Oh, whoops, I didn't find similar yet. Okay. And now we see economists are similar to survey researchers, market research analysts. And this one's interesting, compensation benefits and job analysis specialists. It's kind of funny because we're doing job analysis right now. So kind of makes sense. So you can try this with any occupation and maybe there are some uses for that too. And so those are really all the tools we've done. We found similar things. We made this little representation plot. We found the gaps and gluts between something. Here, look, let's say I'm an economist and I want to become a compensation benefit and job analysis specialist. So then we want to find, what did we call that function? We called it gaps, excesses. So we just copy and paste this code. And instead of human resource managers, I'm going to do economists as the source. And as the target, I'm going to do compensation benefits and job analysis specialists and see what I have to learn. So let's see what I have to learn in terms of knowledge. Okay, I have to learn how to do more customer and personal service, clerical stuff, personnel and human resources. Definitely need to learn more of that. I'm counting on the rest of you guys for that. Therapy and counseling. Okay, and here are the things that I don't need to know as much of. Economics and accounting, geography, math, stuff like that. So you can try this with any job you want or any pair of jobs. And there you go. So that is that's it. That's it. We're done.
Ben, this is, as always, awesome. And I think the beautiful part is you've done all the heavy lifting and the work behind building this workbook, and it makes it so much easier for us to digest and say, oh, this is how you did that, and this is what it does. And thanks for all the comments in it as well, because that also prompts, you know, at least what we're looking at and learning what that is. And looks like Vincent found this amazing.
Oh, nice.
And Catherine is asking, is there a good way to keep track of all the functions you create as you go?
Ooh, good question. Not really, actually, unfortunately. Yeah, actually, you know what? I think you can type in whose. Yeah, there is. Okay, I just remembered. So if in your notebook, just type in whose at WHOS and run that line, and it gives you a list of everything that you stored, all the data frames, all the functions. Yeah. Oh, can I share my screen again? For sure. Yeah, this is what happens when you type in whose. These are all the things we brought in to the database. So yeah, one thing I wanna reiterate is that I know Estelle, first of all, thank you for saying that I did all the heavy lifting, but I think the real heavy lifting is actually understanding like the data wrangling part in Python. I think that's I think there's still a lot to learn in that, and Anna, I'll beat you to the punch. The HCAP program's got a lot of great resources for learning these tools and skills. I think there's a recording from Bennett on that also.
And we're also having a workshop with Bennett, four-part workshop in August coming up. So just send us a note. I don't know, Stella, can we send, can we also post, we will post in Slack all the information. There's definitely, and Ben, you were also in the first workshops that we ran. So all of this is coming up, and we will continue to, you know, to provide you with additional resources there.
Yeah. And there are a couple of more questions in the Q&A. If we use part of this code, do we cite you? How do we cite you?
Oh, it's open source. I mean, you can cite me if you want, but you don't need to. Yeah, you can just tell people to subscribe to the Revelio Labs blog. That's enough. Yeah. It's so there is, by the way, a lot. So if you go to GitHub, where the notebook is stored, you can search for topics, and a lot of people post their notebooks online. So I know, you know, I teach a class at Stern called Data Bootcamp, and every student has projects, and they all upload their projects on GitHub. So you can find lots of cool projects that you can borrow ideas and code from on GitHub. It's a really good source there.
Yeah. Okay, and one other question that came from Peter: how would you do this for cluster analysis for marketing? What sources of for input would you recommend?
So clustering. Okay, so clustering is kind of the next frontier from this. So basically, I think, yeah, I don't know if we should show how to do clustering, but the fact that I'm on the fence between showing it in the last 4 minutes is should tell you how easy it is. The really hard thing about clustering is getting the representation. So once you have a representation for every entity, then clustering is easy. It's just you import a package that does clustering. There's basically two families of clustering algorithms. One is called k-means, which is kind of a top-down approach, where you say, I want 5 clusters, and then it says like where everything should be. There's also agglomerative clustering, which is sort of a bottoms-up approach where you have hierarchies. You get a whole tree, a whole taxonomy. So you can absolutely use clustering on this, and it's pretty straightforward. But again, like the you know, what separates good clustering from bad clustering is the representation data frame that you use. So when we had rep activities, rep rep skills, rep knowledge. Either of those, any of those could be used as an input to clustering, and the clusters are going to mean different things. So if you cluster jobs based on what's similar based on activities, that's very different than clustering jobs based on similarity of skills. So you have to think really carefully about what is the representation that you want your clusters to reflect. If you're interested in clustering, you know, reach out to me. It's like my favorite topic. The two types of clustering, k-means and agglomerative. So, and by the way, the model for the package for clustering that I'd recommend, the common one is called scikit-learn. I think we introduced scikit-learn for TSNE, and we showed the site and how to navigate it. It's got really outstanding documentation. So you can learn about clustering through that.